Okay, so now what we're going to do today is we're going to do a couple of examples, 3 examples of using what we knew in the last video, what we introduced as far as the shape of the graph and looking at the degree of the polynomial. And we're looking at f of the function f of x equal to a times x to the nth power. And so we're going to look and now investigate vertical and horizontal shifts or translations. So in this first example here, we've got x to the 5th power minus 2. Since it's a 5th power, we know it's going to be odd. It's odd degree, which means it's odd, an odd function, which means it's symmetric with respect to the origin. And so, but it's translated 2 units down. So what we're going to do is we're going to take our function, so it's odd, which means it's going to do this, but since it's 5, right? So we know what x cubed looks like, but x5 is going to be narrower and it's flatter in the middle. So we know that x to the 5th is going to look something like this. So it's going to go flat. It's going to do something like that. But it's going to be moved 2 units down. So it's going to look like this. Okay? And that's how we would graph it. Again, we know that it still goes to the points 0, 1, 1, and 1, negative 1. Okay, so because it always has to go through those 3 points. So I didn't plot it on this one, but we'll do it on the next one. But again, think about the behavior of the basic function, right? So just because we take it to the 5th power, 1 to the 5th power is still 1. Negative 1 to the 5th power is still negative 1. So it's still going to go through those 3 points. So let's look at this one. So I know the basic function is looking at x squared, right? So it's a squaring function. It's an even degree, which means it's symmetric with respect to the y-axis. And so we know it's going to go through these 3 points. We know the basic function. So negative 1. And let me do this one over here. Okay, and so we know that it's going to do something like this. Okay, but now this is the 6th, right? So it's double twice, so it's going from 2 to 6. So we know what the squaring function looks like. So this one is going to be flatter in the middle, but it's still going to go through those 3 points, right? So what's going to happen is it's going to do something like this. Right? But it's going to go down. It's going to still go through 1, 1, but it's going to be flat. So what happens with this? It's a horizontal translation to the left. Okay? So what we're going to do is all 3 of these points are going to be moved. So I'm going to move this one here, and then this one goes here, and this one goes here. So now, but the thing is now it's going to flatten out. So what's going to happen is it's going to come down, still through the same 3 points, but translated, but now it's going to come down and flatten out. Okay? And then this one here, there's a few things going on. We've got two translations, and we've got a vertical stretch and a reflection. Okay? So again, it's an odd degree, which means this is going to be related to a cubing function, right? So we know what the cubing function looks like. So this one here, it's going to go through, it's not going to be flat like these. Okay, so we know it's going to go through these 3 points. Like so. And now what we're going to do is, let's see what's going on here. So all 3 of these points are going to be moved to the right 1 and up 3. Okay? So it's going to go up 1 to the right 3. And then there's going to be a reflection too. Okay? So let's do the reflection. Well, how do we want to do this? Let's do the reflection. No, let's do the, let's double it first. Again, just you have to decide which is going to be easier to do this. So let's double it first. So this point is doubled because of the 2, so all of the values are doubled. So it's going to go from -1 to -2. So this one's going to go here. And then this one's going to go up to here, to 2. The origin's going to not be affected. And then we're going to reflect the points. Well, the origin's not going to change, but this is going to go from -2 to +2. And this +2 is going to reflect down to -2. Okay, so now I can get rid of these 2. Okay, so now this is the 3 points. And now what I'm going to do is I'm going to move the 3 points to the right 1 and up 3. So I'm going to move this one to the right 1 and up 3. And so let's say it's going to be right. Hold on, let me. So we're going to go to the right 1, up 3. 1, 2, 3. So it's going to be right here. And this point is going to go to the right 1, which is going to go to 2, and then up 3. 1, 2, 3. So this one's going to go right here. And then the origin is going to go to the right 1 and up 3, which is going to go right here. And so what happens? We're going to get something that does, it's going to be, this is flipped, and then it's stretched. So in this case, it's going to look something like this. Like that. And so, by just using these 3 points and understanding the reflections and the translations and the transformations that are going on, you can move those 3 points and move them around, and then with those 3 points you get a general idea. So again, this is a vertical stretch, so it's narrower, and then you're reflecting it. So now instead of doing this, now it does this. And then now you just move it over to the right 1 and up 3, and you've got your graph. Okay? And that's it. So again, just using what we know from our toolbox and the new information about how the degree, the even or odd degree, and how big it is, as it increases, how does it affect the graph? Okay, that's it. Have a great day.